Hi, this is Morgan. I'm a senior product engineer in the ArcGIS Enterprise development team, and with me is Ching-Shi, who's also a product engineer from the same team. In this session, we're going to go through ArcGIS Enterprise administration with a focus on advanced administration functionalities and concepts in ArcGIS Server. So let's get started. Here are the topics we will cover. We'll take a quick look at ArcGIS Enterprise and ArcGIS Server as it relates to the enterprise. We'll go through applied monitoring techniques and tips. We will look at tuning and configuring services, expanding your site, multi-machine site administration, and some other administrative functionality and topics. So to start off, let's take a quick look at ArcGIS Enterprise. ArcGIS Enterprise is Esri's foundational software system for GIS, powering mapping and visualization, analytics, and data management. It is the backbone for running the Esri suite of applications and your own custom applications. The primary components of ArcGIS Enterprise are Portal for ArcGIS, ArcGIS Server, both of these fronted by the ArcGIS web adapter, and additionally the ArcGIS data store. Here, the ArcGIS Server plays the role of a hosting server, and this deployment is what we term as the base deployment. Additionally, we can federate other server roles to this deployment. These include your traditional GIS server, which has mapping functionalities, GP services, geocode, and others, image server for imaging and raster analytics, GeoEvent server for real-time data streams, and GeoAnalytics server for big data analytics. Recently, we've also added mission server and notebook server to this list. Now, let's delve a bit into ArcGIS Server. An ArcGIS Server site is the logical grouping of machines powering web services. These machines have the same hardware specifications, the same set of services, shared configurations, and have access to the same data. So you have this two-machine or two-node site here, and as you can see, the ArcGIS Server machines read from and write to shared configurations. The machines will also need access to data. This includes the ArcGIS data store, which basically deals with ArcGIS managed data, like things that contain the hosted services data. And then we have data stored in ArcGIS Enterprise geodatabases and file stores or cloud stores, depending on the type of server role you have. You will of course have the ArcGIS web adapter that distributes requests coming from clients. And as you can see, there is the federation aspect, which federates the server to an ArcGIS Server portal to complete the enterprise deployment. From an ArcGIS Server perspective, there are three primary facets of administration that an admin has to go through: monitoring, configurations or tuning, and scaling. These are not necessarily always in a specific order. One way to think about it is that once you have a deployment ready and required services published, you likely use the default configurations and start monitoring your system. Over time, this monitoring results in some configuration changes and some tuning that is necessary. And then you may decide after more monitoring that you need to scale out your site to more machines in order to serve out more requests or handle traffic. We will look at some aspects of each of these throughout this session. Our first facet of administration is monitoring. We will look at out-of-the-box functionality that is available in ArcGIS Server to allow you to monitor and inspect your system, as well as aid in troubleshooting and capacity planning. So we'll look at things like usage statistics, request ID, job ID tracking, and some other quick tips. Let's look at a very useful feature available for monitoring your enterprise, usage statistics. This is a useful tool included with ArcGIS Server for monitoring service usage, for services including hosted services and all of your server published services. Statistics shows information such as total number of requests over a period of time, average response times of requests over a period of time, max response times, number of timeouts, and count of running instances. You can get these statistics over various time periods, including last hour, last day, last week, etc., or a custom time period of your choice. You can also get statistics for individual services or a combination of services within a folder, and also create statistic reports for the whole site. Statistics allows GIS administrators to tune service instances for GIS services based on historical usage to better utilize available resources, identify peaks in usage and plan accordingly, and also use it for capacity planning. You can also additionally combine statistics information along with information from the logs to gain insightful information when you're troubleshooting an issue in your ArcGIS Enterprise, especially issues that are performance related or related to slowness in your site because of service usage. In the earlier slide, we saw how statistics reports show up in ArcGIS Server Manager. Here we see how it looks in the administrative directory. It is under usage reports in the root administrator directory of ArcGIS Server. As you can see in the screenshots, you can update additional settings here like enable, disable usage reporting, how long to keep it on disk for, and how granular you want the data points to be. Default frequency of a data point is 30 minutes, but you can bring it down further, although this will potentially affect the performance of server as you go lower, so you need to take that into account. You can also select individual reports and filter them by machine as well from the administrator endpoint. From the administrator endpoint, you can also generate or export reports in other formats in addition to what is available in Manager like HTML or JSON, whereas in Manager only the CSV format is available. Additionally, you can also create multi-metric reports as you see here. This means you can get a single report that provides total requests count and maximum response count, which are two separate metrics for services or a mix of services combination that you want. And this allows you to create more complex reports that contain these multiple matrices. This is useful especially if you want to export this data out to a more sophisticated reporting system that can then read this data and generate complex graphs or other visual representations that may be needed and that's not at this point available in Manager. Next, let's look at an improvement we made that will enable better troubleshooting and monitoring of your ArcGIS Server site. We have added a field in the server logs called request ID. With this field in there, you are now able to track a specific request through its request response pipeline within the server. This is for all requests that come into the server, and it applies to both REST as well as requests made to SOAP endpoints. Also available is the ability to query the logs using request ID as a filter. This really opens up a much easier experience when troubleshooting issues or even just monitoring the server. Note that while request ID will show up in Manager as a column if you select it, querying using a specific request ID is only available through the administrator endpoint. Here is a look at the request ID being shown in a log query from ArcGIS Manager on the left. You'll need to select the request ID column in order to see this. On the right, we have a picture of the server administrative directory where you can see that I now have the ability to filter using request ID. I can provide one or more comma-separated request IDs and the query will give me all records that have that request ID or the list of request IDs. One clear workflow that you can use here is to basically search for a specific request that has come in by service names or some other means and get the request ID for that request. Once you have that request ID, you can go into the administrative endpoint and search based on that request ID and get the full response pipeline for that individual request and see it from start to finish. So this is an extremely useful tool. Another monitoring enhancement we have is the ability to view and update status of geoprocessing jobs from the Manager user interface. You can go to Site, Jobs in ArcGIS Server Manager and select a particular asynchronous geoprocessing service and get the job details for it. You can then select the status that you want, like submitted, executing, succeeded, etc., the age or duration, and any machine filters and hit on query. You will then get all the jobs for the service based on the filters you've selected. The results show details like status, start, end times, duration, machine information, and an info button that will list additional details. You can also cancel or delete jobs as needed. You can also use the info button to get more details and get a job ID hyperlink that will take you to the job details endpoint of that particular service. This feature allows admins to periodically monitor all jobs in the system and tune the services accordingly, and also better prepare for traffic in the future. Let's quickly go through some additional functionality that helps with monitoring and troubleshooting. These are existing functionalities or functionalities that have been recently added. First, we now log the wait time information for server-based GIS services. This is basically the time that a request for a service from a client waits before it gets picked up for execution by ArcGIS Server. This is logged at the fine log level, and it is useful when looking at performance issues or performing capacity planning. Also, we now have information about expired or expiring licenses that is now added in ArcGIS Server Manager user interface. So if any of your server licenses are expiring within the next month or have already expired, the software authorization wizard will show you that information in ArcGIS Enterprise Manager itself. We also have now disk space monitoring available across the board for all three major components of the ArcGIS Enterprise: Portal for ArcGIS, ArcGIS Server, and the ArcGIS Data Store. When an intermediate threshold, currently this is 10 GB on your installation drive, is reached, there is a warning logs message that is logged periodically until more disk space is cleared. This is your cue as an administrator to start looking to clear some space or add more. When a critical threshold is reached, by this we mean bad things are going to happen, and probably really bad, we will log a severe message every minute. Once you're at this level, some action is required to avoid things starting to fail, which is imminent. We also roll over some of our internal logs. These are logs most of you may be unfamiliar with, and maybe some are familiar. We found that for some customers this was causing disk space being full issues, and hence we have implemented automatic rollover for these internal logs. Now this is not a monitoring change as per se, but we did want to mention this as an informational thing here. We also have added logs that indicate when file logs have been acquired and released when performing administrative operations on the ArcGIS Enterprise or ArcGIS Server site. This helps with failures where you see a message like similar to another administrative operation is being performed when you're trying to perform an operation. Many times this is due to internal logs not being released, and this helps get more details with such cases. This is primarily helpful when you want to provide logs to Esri and who are trying to help you or talking to tech support and getting more useful information to them. We also have included hardware information, including RAM, CPU, and processor information for ArcGIS servers, and this is available through the Administrator REST API. Now I'll hand over to Ching for talking about tuning and configuring services and also expanding. Ching?
Thank you, Morgan. Now you have tool and resource to monitor your ArcGIS server site. Then you may find some servers need to be tuned and configured to meet the request demand in order to optimize your service instance and machine resource. In this section, we are going to focus on tuning and configuring non-hosted servers which powered by ArcSock exe process and the shared instance option in your ArcGIS server site. Tuning and configuring service property here do not apply to hosted servers in Portal, but we added additional resource at the end of the presentation on how to manage your hosted feature layer. There's two ways to configure your service, from ArcGIS Server Manager and from your ArcGIS Server Administrator directory. The screenshot here is the overview where you can configure your service property in ArcGIS Server Manager, and we will discuss the configure service parameters, capabilities, pooling, and process. Those service properties are configured for dedicated service instance type. In other words, configure the service property here for one service will not impact on other servers. Let's start with the service parameter. We will focus on those areas that we found most users have questions from previous conference. First, is the data field setting. If your map or feature service contain data fields that need to be stored in the local time zone, specify the time zone, allow the service to correctly convert and record the date and time value based on the local time you specified. For example, if Arizona time zone is specified in this map service with a feature access capability, when you add or update a feature on the service, the data and time will be based on Arizona time. Even the editor may be located in the Eastern time zone. If you do not specify this time zone, the time will be assumed to be stored in the UTC. The next one is the max number of records returned by server. This property specifies how many records can be returned by server to a client for a given query operation. For example, when you make a query and certain map extend, you notice not all the features are returned or displayed. This may due to number of query results exceed the maximum number of records returned by server. In this case, you can increase this value to make sure all features are returned. In other scenario, when a service with a high volume of feature and it's not necessary to return them all, you may want to limit the number of records returned by specifying a smaller number of this property. Please be aware that specifying a large number of records to be returned by the server, you may experience some delay for your client application to render those query results. The next one is the log data schema. This setting only applies when the service was published by register with its Enterprise GL database or Enterprise database with ArcGIS Server site. This setting do not apply for register folder that contain your file GL database or shapefile. Also, the service is published by copying data to ArcGIS Server. This property will not apply. When you enable this property, which is a default setting, the source data which servers are referenced from is protected from any data schema change, such as a delete or add a data field to the service. And this setting only protects from schema change, and editing existing data still allowed, such as add or delete a feature or records on this table from the service. And disable the setting will stop ArcGIS Server from placing those schema log, which means you can update the schema change, for example, adding a column of your table on your service when the service is still running and used by other user or application. And then you can restarting those servers to see the data schema change. For the capability tab, you can change service specific setting. Enabled capability for each service are checked. In this example here, the service has a feature access capability enabled, thereby giving it a feature service URL. The allowed operation associated to the service capability provides you the option to which service operation you want to enable or disable. For example here, I enabled the extract operation for the feature service, which allows the editor to extract the copy of the data to the file geodatabase or the SQLite database using the custom application. Let's take a look at the pooling setting for the service. In your ArcGIS Server site, you may have different type of service that require different service level of agreements that take different amount of time for processing individual requests. Some operations take few seconds, whereas some taking a long time. Configure timing out setting are important here. First, usage timeout. The maximum time a client can use the service. This is useful when you have the service have some operation that taking a long time to complete. If you expect this long time, you can configure a higher value for that service. But if you don't want a request to use resource for unlimited time, you can use the service usage time to limit how long the service instance can run in. For instance, when there's a stale database connection, you want the service instance to be released after a certain amount of an instance running time become available for the next request. Use the same example for the service instance has long running time, or a service has received multiple requests simultaneously that all instances in the use. The incoming new request will wait in queue for next service instance to be released to take in this new request. In this scenario, you may don't want the new request wait for unlimited time. So by specifying this maximum time a client will wait to get a service, it set the wait time limits for this new request. When there is a long waiting time for the new request, this may manifest to a user as a performance delay. For example, a hanging geoprocessing job or a map that's slow to zoom. Once the request is fulfilled and completed by the service instance, idle time determines how long the service instance can stay active. After the maximum idle time is passed, the service instance will be determined and only keep the minimum number of instances available for that service, unless there is another request received to the same service instance. Next in the process tab is the recycling settings. Service recycling will recycle out all the stale or unused service and reclaim the resource taken up by the stale services. During recycling, all the active service instances will be recreated based on the recycling interval and the recycling starting time, except those instances that are in use by clients. They will be recycled after the instance are being released. All service instances are not recycled at the same time, and services are recycled one instance at a time to ensure that instances remain available and to avoid performance hit caused by creating the new instance of each service. Before we introduce the next service pooling property, it is important to understand what powers the non-hosted service. They are the service instance and ArcSoc.exe process. ArcGIS Server performs all its work through the usage of an instance, and the instance is executed by a computer process called ArcSoc.exe process. One service instance seen in your ArcGIS Server Manager can correspond with one ArcSoc.exe process, and each ArcSoc.exe process taking up a certain amount of memory that ranging from 100 to 200 megabyte of RAM. For example, when a request is made to a non-hosted service in your ArcGIS Server, such as panning a map, this request is received by a service instance. Then, an ArcSoc.exe process will execute this request on behalf of the service instance. So to manage your service instance, you can adjust the maximum and minimum number of instances that will be assigned to the service per machine on the site. The minimum number of instances will make sure the service always has a number of active ArcSoc.exe processes to execute the incoming request. For example, when your service often receives multiple requests simultaneously, you can increase the minimum number of instances, which will add more ArcSoc processes on your machine to execute those requests. When your service occasionally have heavy load of requests coming, you can increase the maximum number of instances, which only add more ArcSoc.exe process when it's needed, and the number of ArcSoc process will return to its minimum number that's specified once the request completes. The ArcGIS Server will scale the number of active ArcSoc process up and down within this defined range based on the current traffic. To monitor and view the status of your ArcSoc.exe process on each machine, you can go to the Task Manager, add a field called Command Line under the Process view. the command line contains information about corresponding service with its service name. So far, we have discussed how to tuning and configuring service property for individual servers to meet different service demands. We call the service instance type as a dedicated service pool, meaning each service has its own dedicated service configuration. So what happens if you have many relatively low traffic servers on your server site? It's worth noting that more ArcSoc will increase the RAM usage of your ArcGIS server machine. So it is difficult to have 100 servers on your ArcGIS server site without increasing your machine memory. Prior to 10.7, you can set the minimum instance as 0 for low traffic service. There will be no active ArcSoc process consuming your machine memory when there's no request. However, the downside of this method is the first request will experience the cold start spinning the ArcSoc process and increase your machine memory during this time. The good news is, start with 10.7, we introduced the shared instance as solution, which will save the machine memory without compromising the performance of the first request. So what is the shared instance? The goal is to save your machine memory by pooling and using the shared ArcSoc process by multiple qualified services. The shared instance is intended for the service have relatively low traffic, or the service that receive a small amount of periodic request, or the service that do not receive the concurrent request. So how the shared instance work? For the qualified service type, you can publish them as a shared instance, and unlike the dedicated instance service, which has its own dedicated ArcSoc exe process, for each service, the shared instance service will use one of the ArcSoc process in the shared instance pool. For instance, when there is a request is received by a shared instance service, this request will be executed by one of the available ArcSoc exe in the shared instance pool. And once the task has done and the request has been completed, the ArcSoc is released and become available to be used for other shared instance services in that shared pool. So what service type are qualified to use the shared instance? Your map service and map service with capability with feature access, WFS, WMS, and KML. And also, you need to publish service from ArcGIS Server Pro. And cached map service published from ArcGIS Pro and meet above requirement and also qualified as a shared instance. And we're also planning to add more service type in the future release to be used as a shared instance. Here is an illustration of my ArcGIS server site that have multiple servers that are all the services using the dedicated service instance type. As you may see that for those servers, for example, the map service 2, feature service 2 on the right side of the slide have a minimum 0 or 1 instance, service instance. This is because they receive relatively low traffic requests. I also have the map service 1 have a higher volume of request traffic with a higher number of minimum and maximum service instance to serve the high traffic service request. Now I want to take advantage of the shared instance by consolidating all the qualified low traffic servers to use the shared instance pool. This way, my user won't hit the cold start performance issue and also save my machine memory with a less number of ArcSoc exe process running in the background. So how that work? Now you can see that all the qualified low traffic servers are moved into my shared instance pool, and there are always 6 ArcSoc exe available to taking any incoming request for those services. But for the high traffic service map service 1, I still keep it as a dedicated instance type and adjusting its adjusting its property depends on the service traffic defined. And also, if I found there's a decrease of service traffic for the map service one, I can always change it to the shared instance pool at any time. So in summary, there are advantages or conditions for using both shared or dedicated instance type. You may want to consider using the shared instance type for those qualified services that receive the low traffic request. And please be aware that because all services share the same instance pool, they have the same service configuration, whereas the dedicated instance service can have its own service property configuration, and it supports all service types. So to configure the shared instance service on your site, you can either publish or switch individual service as shared instance, or set the shared instance type as default on your ArcGIS Server site. To switch an individual service to use the shared instance pool, you can change the instance type service under the under its pool property. You can change a service instance type at any time. If the service type is not supported as a shared instance, this option will be grayed out in your ArcGIS Server Manager. To set the default instance type as the shared instance on your ArcGIS Server site, you can update the default instance type as shared instance using the pooling page under the Site tab in your ArcGIS Server Manager. Then, all the compatible servers will use the shared pool by default. There's two properties that you can configure for the shared instance pool. You can change the number of ArcSoc running in your shared pool at any time. Unlike the minimum to maximum range you set for your dedicated instance type, the shared pool runs the fixed number of instances. The default value for the new site is based on the number of core available on your machine. You also can change the cache size. This is the number of servers which configuration are cached in the memory and do not incur any overhead for the first request. Although the shared instance servers do not have the traditional cold start problem, there's still a little bit overhead for the servers that are not in the memory. The default value is 50, but you can change the value if you have a more commonly used service. We have discussed how to optimize your service instance. If this does not satisfy your request demands on your ArcGIS Server site, let's begin by looking at expanding your ArcGIS Enterprise. We look at when you may want to consider to expand your ArcGIS Enterprise and what option that you have to expand and how to expand with focus on scaling up your ArcGIS Server site specifically. So you have your base enterprise either in production or in the staging environment and preparing for production. Regardless, you may have a plan for expansion. So when you should consider to expand your enterprise site, you may experiencing the increasing load or usage of your web map, app, or other services. Or you may want to utilize additional capability by adding different server roles, such as geoanalytics for analyzing the big data, or ArcGIS Server image server for storing and processing a large collection of imagery. Or maybe you want to separate your server for the workload, where one server is designated to serve heavy geoprocessing jobs that require large amount of resource, but other server can be used for the usual site operation. Or you want to have the high availability for your ArcGIS Enterprise site. And all of those are good reasons to look into expanding your enterprise site. So let's start with looking at options that you have to scale each component of your enterprise. For ArcGIS Portal, you can have the primary and standby, mainly for the high availability use. For ArcGIS Server, you could expand in two ways. You can have a multiple site, meaning you can create multiple ArcGIS Server sites, or you can have multiple machines to add it to your ArcGIS Server site. For example, you can add 1 or 2 machines to your hosting server site or any other ArcGIS Server site. For the data store, you can have you can set up the primary and standby relational and tile cache data store for high availability use case. Or if you're using the spatial temporal data store, you can add multiple spatial data store for workflow that have a heavy computation requirements. As ArcGIS Server is perhaps the component that undergo this process most. So in the next couple slides, we're going to take a close look how to scale up your ArcGIS Server site in this case. So we will talk about the first way to expand your ArcGIS Server by adding more ArcGIS Server sites to your deployment. The possible use case could be to isolate your hosting server from other specialized ArcGIS Server role. For example, you can add another ArcGIS Server site that is federated with your ArcGIS Portal, or add other server roles like Geoanalytics Server or ArcGIS Imagery Server. Or you wanted to separate the workload or even separate ArcGIS Server sites based on the service type. Perhaps some of operation requires more CPU intensive like routing service. To create another new ArcGIS Server site, and you may first need to provision the machine with the hardware resources you want to and install ArcGIS Server on them, and then licensing your individual sites with appropriate license. Then create a site and federate the site with your portal and bring it into your ArcGIS Enterprise. The diagram here depicts some of the possibilities. The other way to expand your ArcGIS Server is to add more machine or nodes to your specific ArcGIS Server site. The use case could be, you may have the heavy usage of built-in analyze tool or high number of insight for ArcGIS user. Or you have a hosting server have a double duty, not only serve as a hosted service or hosting server, it also serve out as a dynamic MAC service or running geoprocessing jobs. Or you may need more computation power for analyzing the big data on your geoanalytics server or other server role. Or you may have a heavy geoprocessing job that being performed and need more resource, thus need more machine. Then how do you prepare to add more machines to your ArcGIS Server site? There are some prerequisites that need to be met before you adding additional machine. You may have used a local file path on a promise system to create a single machine ArcGIS Server site. When scaling to more machine, you want to move a shared location for your configuration store and server directories. So you will need to edit those paths to a shared directory. And all servers that you published will be duplicated on all machines in your ArcGIS Server site. Then it is ideal to have the machine process the same hardware resources and have the same operation system. And make sure they have all the same ArcGIS Server version that they install. The exact same license need to be applied for all machines in your ArcGIS Server site. Please note that this includes the expiration dates. And all machines should use the same ArcGIS Server service account. And ideally, this is a domain account for your Windows. For Linux, this can be an account that have the same group ID or user ID on a Linux machine. Also, the ArcGIS Server service account mentioned just now need to have read and write permission to the shared directory and configuration store location. This allows our machine to perform appropriate read and write from and to the configuration store and directory. Ensure machines can communicate with each other using the designated ports as mentioned in the documentation. This may also require adjusting your firewall setting on your network. And of course, you also want to make sure the ArcGIS server on all machines can access all the data. Once all those requirements are met, the next step is to add additional machine or machines to ArcGIS server site. There's two ways to do that. You can add the machine on your ArcGIS server manager of existing site and perform an add machine operation using the machine name and URL that you want to add. And next is the join site. You can use the ArcGIS server manager of the machine you want to join to the site and use the join site operation to join the machine to the existing ArcGIS server site. And you can of course automate this process using your ArcGIS server admin directory endpoint as well. There are a few additional considerations to take into account when adding additional machine to your ArcGIS server site. First, we recommend using the web adapter or reverse proxy in front of the ArcGIS server site. This will allow it to route the request among machines in a site. A bit background here. A few releases ago, we deprecated use of cluster or rather multiple clusters in a ArcGIS server site. This meaning there's no longer this internal load balancing that occurs among machines in a ArcGIS server site. A request that comes to a particular machine is processed completely by that machine, and that machine responds back, so there's no routing to other machines in the site for a service request. Then using the web adapter or reverse proxy is necessary when you have multiple machines in a site. This also affects federation. When you federate your ArcGIS server site with your portal, this recommendation is use the web adapter or reverse proxy URL as both the service URL and the administration URL. As you can see in the screenshot here, the service URL is usually the web adapter or reverse proxy URL, but we also suggest to use the web adapter or reverse proxy URL for the administration URL as well when you federate. This ensures the federation to portal for ArcGIS server. ArcGIS is not tied to any specific server machine in a site. So if that machine gets unregistered or need to be taken out, your federation with portal is not broken. A last note on here, we do suggest using two web adapters if possible. One with the administration enabled for the admin URL, and another one is without administration enabled for the service URL. You may have the question that, what if my ArcGIS server site have already federated and now I want to scaling up my server site? Well, you can update the administration URL for the federation server using the portal sharing API, and to complete that workflow, you will need to additionally validate the server from the portal admin directory. A note here, this workflow is assuming that you are using the web adapter on the reverse proxy for the service URL already. If you're not using the web adapter URL for the service URL, unfortunately, and there's no easy workflow. So if you're in this scenario, please contact our technical support for further assistance. Here we have discussed how to expand your ArcGIS Enterprise site. Now my colleagues Morgan will further discuss how to administrate your multi-machine sites.
Thanks, Ching. So in this section, we will talk about multi-machine site administration, go through some helpful concepts and some common issues with multi-machine configurations, and some functionalities to mitigate them. So we thought it would be relevant to make you administrators understand the difference between the two request types that come into a server site: service requests and administrative requests. Now I promise this will be useful when we go through some of the issues in later slides, so bear with us. Service requests are requests to a service endpoint for a supported operation. So it could be something, a request to a map service, hosted feature service, image service, etc. Service requests, when they come in, the request is handled by the machine which receives it. No modification to site configuration is usually needed, and examples are querying a map service record, passing edits through a feature service, etc. Administrative requests are requests that come into the server side to add or modify configured information. In this case, request is handled by the machines or the machine which receives it and is then propagated to additional machines in the site. Examples are publishing a new service, registering a data store, and other administrative operations like that. Now let's look at how these two request types are handled within a multi-machine server site. Service requests first. An incoming request comes in through the web adapter. It is then routed to one of the machines in the site, in this case machine 1. The server machine accepts the response, processes it, and sends a response back. The other machines in the site are not involved here, and there is usually no updates to the site configuration. Next, administrative requests. An incoming request comes in through the web adapter. It is then routed to one of the machines in the site, in this case machine 1, like before, like in service requests. The server machine accepts the response, and as part of this publishing or administration workflow, it will update the site configuration with the changes. Once this is done, the other machines are notified to pick up the changes that have happened. And this is different from regular service requests because you're making a site configuration change as part of any publishing or administration workflow. The other machines sync up with the updates and the original machine responds back with a success. With that understanding, let's now take a look at some common issues that our customers have reported with multi-machine sites and look at some functionality that can mitigate those. First, my site performs poorly when one of the machines in a multi-machine site is unavailable or is not reachable or is down. So you have an ArcGIS server site with multiple machines or nodes. There's always the chance, especially when you have several nodes, that one or more of them could be unavailable. Unavailable could mean ArcGIS server is down on that machine, or the machine itself is down, or there are connectivity issues to that machine. In environments like the cloud, this could also just be a case of the machine being down or taken out by your autoscaler logic, or even being shut down or destroyed. In all these cases, when a node or multiple nodes are unavailable for very brief periods, there is slowness, but this usually sometimes does not last long, but it could potentially last long. As an example, let's say we have a publishing request that comes into a server site. This could be publishing a map service or a hosted feature service, etc. The web adapter routes it to one of the machines. The server machine accepts and processes the request, and because it's a publishing operation, makes updates to the site's configuration to add to this new service. The machine then instructs the other machines to sync up, in essence, to deploy the service on each of them. But the request to machine 3 does not go through since it is unavailable. That internal request waits and eventually times out. This means the administration process that should have taken 15 to 20 seconds now has taken 4 to 5 minutes or up to 6 minutes. Now imagine the situation whenever you publish or administer the site when one of the machines are down. This is causing the site to become very slow and sluggish. And we've added features to help with this. As of 10.7 and beyond, each node or machine within an ArcGIS server site will periodically report its connectivity status. So this connection status is basically a report that a machine can connect to its config store. When a machine does not report this heartbeat within a set period of time, it is marked as suspended. Suspended means that when any administrative operations like start, stop service, or publishing happens, these are not propagated to machines that have been suspended. The threshold for suspension is configurable as a system property in the server admin. Once the machine is back up and reporting its status, it is unsuspended and syncs back with the site. Our testing shows much improved performance with these changes. There is a significant improvement in the experience of administering of a site and publishing in such scenarios. The experience is almost comparable to when no nodes are down and admins as well as users are happy. Additionally, there is another threshold where machines that have not reported their heartbeat beyond this new threshold are automatically unregistered from the site. This is especially useful for cases where the machines are never coming back or are down and out. So these are the two thresholds that I talked about, the machine suspend threshold and the suspend machine unregistered threshold. Another thing we have heard from customers is the ability to perform updates or maintenance to individual machines or one by one to all the machines in a multi-machine site without much service disruption, where all the other machines can still take in requests and perform as they were performing earlier. So this is where under maintenance mode comes in. So there are many scenarios where you have to do planned maintenance on the machines that are part of your ArcGIS Server site. This could involve shutting these down or just installing certain software or running some system operations, or in some cases load some data locally onto these machines. Regardless of what it is, you ideally want to do these either on one or a set of machines at a time to avoid too much downtime. And you want your load balancer to temporarily not send load to these machines. There is no way to tell this to your web adapter or reverse proxy through an API as of now. This is where the under maintenance property comes in. Basically, you can mark specific nodes in your site as under maintenance. This will result in the machine health check for that particular machine returning false. The ArcGIS web adapter will honor this and not route requests to this machine. This will also work with third-party load balancers or reverse proxies as long as they depend on the server machine health check to determine whether to route requests to a server machine or not. The web adapter will start routing requests to the machine once under maintenance is set back to false. So in essence, this provides more control of the maintenance process and provides a means to minimize downtime during any kind of maintenance. You can mark a machine under maintenance sometime before its planned maintenance. This allows the web adapter or your third-party reverse proxy or load balancer to know that the machine should not be sent requests in advance. Then when you're actually bringing these machines down or the machine is in some state where it cannot accept requests, there is no service loss. A third scenario that is commonly asked about is where you as an admin want to control and enforce when publishing or any admin operations are done to your site. You have set limits on when people can publish in terms of time, but there was no way to enforce it. Also, you want your server site to function even when there are temporary disruptions to the shared site configuration that is on some file share somewhere. You may ask why I have lumped these two together. Well, next slide. So that brings us to the read-only mode feature in ArcGIS Server. Now this is not new, it has been there for quite a while, but we wanted to go over it because it is useful and is relevant for the scenarios I mentioned earlier. So let's explore read-only mode. How does it work? Essentially what happens is the site becomes locked down and allows or disallows any publishing or administration events to happen in the site. There are some exceptions here like add or remove machines, and we have listed those exceptions in our help doc. Additionally, the site configuration files are copied to a local repository on each machine in the site. And this local path is configurable in the ArcGIS Server administrator directory. So benefits of read-only mode, of course, it allows admins to enforce publishing and administering tasks, which means that you can enforce that publishing be done only on certain times of the day or only during the weekends, etc. Additionally, because we are copying the configuration files locally to each machine in the site, any temporary disruptions to the shared config store or the configuration store will still allow the site to function in a degraded mode. So for example, a file server that contains the site configuration is unavailable temporarily. With read-only mode, the site is accessible, most services and operations will continue to work. Without read-only mode, if the site is not set in read-only mode, the site is pretty much dead until access is back. So let's look at how ArcGIS Server read-only mode relates to the new ArcGIS Enterprise read-only mode functionality that's come in. So ArcGIS Enterprise read-only mode is a functionality where the entire ArcGIS Enterprise is put into read-only mode, and primarily for functionality like upgrades or workflows like upgrades, where we want not too many changes to occur when upgrades are happening and we want to keep the state of the deployment. So you can set ArcGIS Enterprise read-only mode when performing upgrades, which basically freezes the state of the deployment while it is in this read-only mode. It also prevents edits to feature services as well. Now ArcGIS Server read-only mode can work in concert with ArcGIS Enterprise read-only mode. ArcGIS Server can be put into a read-only mode without Enterprise being in read-only mode. So this is what we have with multi-machine site administration.
Thank you, Morgan. The next section, we're going to talk about other administrative functionality. We're going to discuss the fine-grained privilege model for your federated server and also the system property for your ArcGIS server sites. So what is the fine-grained privilege model? What does that mean? Before 10.8.1, if a portal member who has any of the administrative privilege, such as a member has only the manager license privilege, this member not only can log into the ArcGIS Server admin directory, but this user can also access all the API resources to take any actions they want, such as delete ArcGIS Server site or changing the server security setting. With this enhancements in 10.8.1, we restricted a member access to the federated ArcGIS Server admin directory based on the privilege that are assigned to their role. And then this feature is implemented for the federated server only. So if you have a standalone, you won't be impacted by this enhancement. Now, who can access ArcGIS Server admin then? The primary administrator or the full admin, or a member has any of the highlighted administration privilege in portal. They are update item, delete item, security and infrastructure, or manage server privilege, or a member who has any of the publishing privilege. So therefore, a member who met any of the condition can access ArcGIS Server admin directory. So if you are not met those conditions, for instance, if a member who only has the managed license privilege will not able to log in the ArcGIS Server admin directory. And furthermore, for the member who has the privilege log into the ArcGIS Server admin directory, some of the server admin APIs or resources may be further restricted depends on what privilege that member has. For example, here, if I am the portal member who has a managed server privilege and log into the ArcGIS Server admin directory, I can only access those API resources that I have permission to access and blocked from accessing those API that I don't have permission. In this case, I cannot export or import site or delete the site, which only the full administrator can perform. There are some special properties that you can set on your ArcGIS Server site for a variety of use cases. They can be configured from ArcGIS Server administrative directory. The properties are specified as a JSON, with each field in a JSON representing a property and its value, like illustrated in this screenshot. There are several system properties that you can set for ArcGIS Server, and we will go through a few of them as an example here. The web context URL. This allows you to define a web front end as seen by end user. This is useful when you have configured one or more reverse proxy server to front of your ArcGIS Server site. so your end user do not see any information of your internal servers. Then you have a local temp folder. This defines the local folder on a machine that can be used by GIS services and objects. If this property is not explicitly set, the system's default temporary directory will be used. If this property is used, you must create the temporary directory on every server machine on the site, and this property only applicable for ArcGIS Server site that installed on Linux. There are also several forward proxy related property. A forward proxy server is a computer on your local area network that allow you to connect outside of the network without compromising the security of your internal network. For example, the printing tool service or custom geoprocessing service in your ArcGIS server site may need to access the external web service. If your organization uses a forward proxy server to connect externally, you need to configure the ArcGIS server to use your forward proxy server. This is where the proxy setting property comes in. You can provide the proxy host, port, user, or password, and optionally set the password to be encrypted using the HTTPS proxy password encrypt properties. Next, we added some additional resources for the topic and content you might be interested in, and some area that we couldn't cover within this 1 hour presentation. Thank you again for watching our presentation and this video.